So today we're going to be talking about my talk on Meshy Marts. Are data products just data marts? Is it all a big mess? I'm sure everybody has been following data mesh for quite some time. So we're not really going to go into that. We're kind of assuming that you've got a little bit of base knowledge around that. But yeah, a little bit about me. I actually originally trained as a saxophonist, worked on cruise ships before deciding that was a terrible career path and moving into data originally as a DBA on SQL Server, and then moving into kind of wider data roles as head of data and that kind of stuff, a bit of time with consulting, and now as a solution architect with Firebolt. I'm generally interested in technology and kind of solving some of those hard problems. So that's a little bit about me. So the first thing we're going to do, we're actually going to get a little bit interactive. So I'm going to ask you a question. So if you go to on your phone or laptop or whatever you're connecting on, if you go to www.menti.com with the code 58409865, and I will switch over to the Menti screen at the moment. And there should be a simple question for you to answer, which is, are data products just data marts? So I thought it'd be kind of interesting to get a feel for what people think at this point in time, because on the face of it, they seem very similar, and that it's data tailored for a very specific business area or domain. So is it just the same thing? So we'll just give it a couple of minutes for these to come through and kind of see what people think. And then we'll move on to another very quick question as well, just to get an idea of whether or not you're planning on using data mesh yourself as well. So I just have to log into the other presentation as well, which has just logged me out. So it won't be a second. So we'll just give this another moment to see what's coming in. It's kind of interesting to see the votes as they come through. We've got 14 in, and there are 20 plus people. Okay, so yeah, that's kind of cool. Let's move on to the next slide. So it's about 1/3 to 2/3. So then if we move over onto the next slide, I say, it should be, I say when they've changed all this since I last used it. Using strange tools, that's always good. There we go. So are you considering building a data mesh? If we can just get a feel for the people out there that are doing this, who's exploring, who's definitely doing it, who's definitely not doing it. I think it's just kind of interesting to see some of these things at the start of this talk. So while you're answering that one, I can actually jump back to the slides and start talking about where we're coming from. So I think for this talk, we need a quick recap of a data mart and a data mesh product. So if we look at Bill Inman, who this particular graphic is taken from his book, the department level of his architecture, which is commonly known as a data mart, sits between the atomic data warehouse and the individual consumption of data. And I think this is a key point in the discussion. As under this architectural model, the data mart pulls all of its data from the data warehouse, which contains, quote, integrated historical primitive data that cannot be updated. And compared to the data mart level of data that contains derived data almost exclusively. So that's saying that we have an atomic data warehouse that is entirely populated by source, and we don't change data within that, compared to the departmental data source, which is for our data marts that's going to be consumed. It's all derived data at that point in time. We're kind of into the facts and dimensions and so on. And sorry, I just saw the comment in the chat there. And it's done for consumer requirements. And so the operation goes through the stages of very much of a pull. The data team is responsible for building most of these things from the atomic data warehouse onwards, and they're pulling data from each layer to the next layer. And I think this is going to be a key point when we start talking about data products, the difference between a pull and push. If we take the stance that Kimball's approach is really the same fundamental approach of the consumer shaping the requirements for a data mart, it's got the same pull mechanism, although we kind of skip the atomic data warehouse part a little bit and just join those dimensional models together with a conformed dimension approach. So data marts are really reliant on the operational data sets, but they're not built by the engineers and teams responsible for creating that source data. Instead, the data mart may be created either by the central data team in conjunction with business users, or sometimes by business users or analysts themselves. They might kind of build on top of that. But usually if they're doing that, they'll be doing that with some guidance from the data team. So if we move on to data products. So here we have a very famous tweet from Zhamak Dagani. There are no warehouses in a mesh. There are autonomous data product quantums that provide multimodal access to domain data for analytical workloads connected together in a graph, each both transforming, serving, controlling immutable bitemporal data. Yeah, I don't know what that really means either. So let's go to my interpretation. Data products are designed to try and overcome the bottleneck of a central data team responsible for the data pipelines within a business. So if we think back to that pull operation, we have a central data team who is pulling that kind of data through into the central repository, and every single user plus every single source needs to get work into their backlog, into their workload in order to get that done. The other problem with that potentially is that there's a loss of domain knowledge. So where we have that pull coming from source systems, the data team don't necessarily know that system inside and out. They don't necessarily know the business problems that are being solved with that application, whatever it happens to be. They're making assumptions. Hopefully, they're communicating with the source team, but there is an element of Chinese whispers that occurs in this space. So in order to do that, the data mesh approach will say, let's focus on the scope of the domain only. Let's start to look at building essentially mini versions of what we saw on the previous slide together. Oh, sorry, am I still sharing? Has that just dropped now?
No, you stopped sharing.
Okay, so let me share the screen again. Can you see that okay?
Yeah, I can see it again.
Yeah. So we're gonna kind of look at mini versions of the entire piece, and that way we then will look at providing that out to people to consume as they wish. And this is in the it's a horrible name in the data mesh terminology for output ports. I just don't really like it. I think endpoints is a perfectly good name, and I don't know why we moved away from that. But the idea is then that we can provide this multiple different ways of accessing that data as the consumer needs. So it could be a file, it could be an API, it could be a sanitized SQL schema, it could be data virtualization. We could also have temporal parts with that. So here's a close of play data set. Here is a close of month play data set. Here is something that's up to the month. Here's something for a certain subset of that. But it should all be controlled within the domain itself. There are other features of a data product outside the scope of this talk from a data modeling perspective. But I think it's a key point to make that they are created and owned by the domain product application teams. So the people that are building their application that's creating this data in the first place should be building the data products that are then consumed by analytical users and owning it. And the owning is a really important part of it. And the way I interpret it is there's absolutely no intention within data mesh to create any kind of enterprise data model. And I think that's what was being meant in the previous tweet, I think. So we're getting away from trying to model the entire business in one space and allowing domains to model their data alone. And then if you need to combine that, you can do. So let's delve in a little bit further. So if we have a look here at a typical modern data platform, And imagining it's some kind of e-commerce company. So tracking, amongst other things, their product catalog, basket activity, and orders. A typical data platform might look something like this. So on the left, owned by the relevant domains, we have our applications with integrations between them, because you can't put a product in a basket if you don't know what the product is. But that's outside the scope of our data platform. We have that data sat in those databases there, and hopefully there's some modeling that goes on in that in those databases by those teams, hopefully, but not always. And then we would have some ETL, or in this case ELTL, because it's extract load to transform load in this case, in order to get the data from those applications and land it into some kind of staging zone and so on. So in the example here, the basket data is submitted as some streams, say. One might be for like basket created and expiry. One might be for product add remove events and that kind of thing. You might have a JSON schema as an event with various bits in there and so on, and push that on. The products are then a batch load process in this. So we've got an orchestration set up by the data team to pull that data into their raw data landing zone. The orders might use some kind of DB level CDC mechanism. So that might be, say, if it's a SQL Server database that writes to its own table, depending on the CDC mechanism that you have, it might push it out into a bucket, or it might not. It might push it onto a stream. But it's a case of there's still a pull really from the data team to take whatever it is that's given there, transform it, do some modeling on it to land it into our data platform. And from those raw zones, we're going to have the key modeling and key transformation of that data. So we'll take all of the data together, try and create our kind of enterprise schema for it, load that into our atomic data warehouse. So this is going to be the event level data that we're talking about. It's immutable at this point. We're not going to change it, but it's coming together so that if you want to ask any questions of the entire schema, the entire business, you can go to that atomic data warehouse and ask it. Then from there, that's where our transformations will take place to provide our data marts and produce our data marts. So we've gone through this funneling process to get to pushing it back out into the business. And this, I think, is the bottleneck that we're looking at trying to solve with data mesh, if you want to go and do it that way. So the ownership for the data modeling for everything other than the DBs on the very far left is done by the data team. And the same applies as we add more and more systems. So if we have some clickstream data or some accounts data or some invoicing data or some payments and suppliers and so on, that all has to come in here. We have to set up the same kind of processes to get it into our atomic data warehouse. The modeling is going to be done by that central team, which is hopefully getting bigger to take care of the additional load. But it's all sat in that same place, run by the same people. And I think this is the challenge and the problem case that the data mesh paradigm was designed to solve. We're comforted that all our data sits in one place, but priorities get in the way. And our data consumers can get frustrated because there's a fair chunk of process and work to be done to get them there. Simple report on, say, how many baskets had product X in on a Black Friday or whatever it happens to be. And so sometimes they cheat and cut corners and they go straight to the source. And I'm sure we've all seen that happen, where rather than wait for the process of properly sanitizing the data and loading it into the atomic data warehouse is done, they just skip it and do something themselves. And then there's some spreadsheet somewhere that is providing that data and turning up usually into board meetings as I find it. So if we look at data products, and to make sure we're all on the same page of this, because this is a conversation that I think is running. What is a data product? I'm going to give my view of how a data product would look. And this is definitely my opinion. It may not be your opinion, and it'll be interesting to see whether or not you agree with that at the end, or whether you have different views. So what I would see is essentially we're looking at a trimmed down version of what we had previously. We have on the left an operational database with, in this case, an event stream going into some raw data storage with some transforms into a baskets atomic data database, and we're exposing that through the horribly named output ports, maybe in some pre-configured sets, maybe in a SQL endpoint, which might have some virtualization behind it, and so on. So in this case, we have our checkouts, our abandoned baskets per day data set, and a SQL endpoint for any other queries that you might want to, any other kind of things that you might want to look at. But what's really different here is there is no reliance on any other domains at all, or any other teams. This should be entirely done within the baskets domain by the basket domain teams. So we should be either embedding data engineers and data professionals within that team, or providing them tooling that helps them do this. And that could be things around, self-service frameworks for doing, say, a Spark pipeline, or, self-service frameworks for creating event streams, standing up databases. IAC is going to be a big part of a data mesh implementation, as I see it. But while we're on the point of the scope of a data product, as I said, there are different views from this. And some people, for example, my friend John Cook, will say that the data product is actually just the output ports here. So we could say that the checkout data itself is a data product. And it's kind of more analogous to thinking of a product where we take a product off a shelf and consume it. But I think in the context of Zhamak Dehghani's work and the wider piece that we're looking at, where she's talking about the data product containing the code that runs it, the infrastructure that it runs on, and various other parts of it, I think this kind of approach seems to make more sense. And the other thing that we could say as well here is that I have a baskets domain and I've got one flow within there. There could be multiple data products within there as well. There could totally different sets potentially. Probably they aren't with baskets. Baskets might be a little bit too simple a kind of a concept to do that with. But when we get into other areas or sales or whatever, and it's going to largely depend on how you configure your domains. So if we take a step out then and look at several what are called source data products. So these would be data products that connect directly to a source of data. So in this case, we have the three that we had from the original kind of centralized data warehouse slide. We've got the baskets that we were just looking at. We've got the orders, and we've got the products. And interestingly here, you'll see that the products is now a simplified process. We have that batch load. So do we need to have a storage bucket to land it into, which is there more from our centralized process? And I think that's kind of a really interesting part of the data mesh paradigm, is that you can now start to design those individual processes much more easily and make them more technology agnostic. So for instance, here we've got storage buckets in the case, but they could be separate clouds. The databases could be different databases. We could have a Postgres database. We could have a hopefully a Firebolt database, but that's the only time I'm going to mention Firebolt today. We could have a SQL Server database and so on. Or they could be on the same infrastructure as well. We could do that. It's the ownership of it is really important. All of those choices then come down to the domain team operating the data product, because they're owning it, they get to build it. All anybody else is really concerned with is the output ports. So what's kind of going on the inside is no longer as important from the external user's perspective. And I think what we should be looking at doing is making this easy for people to build by having their data platform team that the data mesh advocates, providing tooling. So as I say, IAC I think is really important. Frameworks are really important. It's really easy to write some of these frameworks and start getting going to allow people that are less familiar with the data space to starting moving forward. So for instance, you can declare a slowly changing dimension as a function, allow you to pass any data in the columns that you want to build it on, and then you don't have to worry about people creating that logic themselves. They can just reuse it. So as I was saying, here we have a single data product for each domain, but you could have multiple ones in there, and it's going to depend on how you define and frame those domains. And I think a good person to speak to on that is Paolo Plata at Agile Lab. He's got some great workflows for designing that. If you go and look him up on LinkedIn, you should be able to find those. I think it's some really great material. So if you start putting it all together, this is where the mesh part of data mesh starts to be significant. So we're moving into what are called aggregate data products. This is where we're taking multiple data products and combining them together to produce new data sets. Vasily, yeah, there's no real place for an enterprise data warehouse here. There could be the databases could sit on the same database server or the same database infrastructure, but we're not looking at modeling everything holistically. We're looking at connecting things together. We're trying to break away from that enterprise data warehouse. So as you can see on this slide here, I now have two new data products, basket conversion. So in order to really understand basket conversion, I need my baskets data product, which tells me my checkouts, but it doesn't tell me or not whether that resulted in a successful order. So I need some data from my orders data product. And then I've got my order products. In order to get the full detail of my products within there, I'm going to have to combine data from my orders domain with my products domain. So there might be some kind of product manifest export that tells me all the different products, shows me when things were, when things were started to be marketed, price changes, whatever that happens to be. We could have a further domain that's not shown here for, say, fulfillment, that shows whether or not that stuff's in stock or not, and how quickly we deliver that, and so on. There's lots of different things that start to connect together. And I think this is where the first real question for this approach arises. So if data products belong to a domain and have a domain team and a data product owner, as is described in the material, what is that domain? Who is that domain team? Do I literally need to stand up a new team now to say that we have a basket conversion domain and there's a basket conversion team with a basket conversion data product owner running that? Or does it slot into another domain? I don't really think this is really answered yet. And from the customers that I was dealing with when I was a consultant, they kind of tried to slot them into where it made sense. So I think this is an unanswered question, and I'm really interested to understand what your viewpoints are on this particular point, because I just don't think it's answered yet. And there's definitely potential risks of getting into, say, the Spotify model, where you end up with serious kind of resource bloat from a personnel point of view. You're trying to slot data engineers into every single team under the sun, and suddenly you need 100 data engineers, and it's impossible to hire one at the moment. So the other point with this is it's really simplistic when you look at 5 boxes on a screen, which is effectively what this is. But as we add in all of those other domains, this starts to become much more complicated. So if I then have a subsequent data product that needs to combine orders and products, do I go to my existing order products data product, even if it doesn't answer my question? And who owns that change? Does it go onto their backlog? How does it get prioritized, and so on? What if I need to add basket conversion into that as well? Do I combine the two together and create a new data product further down the line? What if I need to take something that has orders and baskets and then products? Am I going to the basket conversion product or the order products first as my first point of call, or I just skip those and create a new one myself? This is where the governance aspect of data mesh really needs to come in. And this is not a data modeling problem at all. This is a people problem. This is you can and can't do this. This is the process that you need to follow in order to stop this just becoming the Wild West or the data mess. And there's a serious risk, I think, of that happening if you just kind of start opening it up and say everybody that has a data set owns their data and creates their data product. So I think that's a really big question that needs answering. Unlike the source data products, which we don't store the raw data in any of these source data, in any of these aggregate data products here, because they're already storing it in the source data product for you. So we shouldn't be copying that data over. So you'll notice there's no raw data storage buckets in here. We're just transforming the data into the data set that we want. And I think that's one thing that's going to really kind of assist with the approach in data mesh as you get further down the side. And back on slide 6, I said that all data products should stand alone. And I think they should. But in this case, if an input port is broken, we can still respond to requests for our data product. We've still got that data there. You can run reports on it. You just have to be aware that it's stale. But it does raise the second question: what about downstream data products from there? So if my order products data product here is broken because the product's data product is also broken, anything that's dependent on my order products data products is also going to be broken. So there starts to be this kind of crazy dependency chain, and it's going through different teams this time to fix that. Is that actually a bigger problem than the bottleneck that data mesh purports to solve by having a centralized data team? It could well be. So I don't think that, there's nothing here saying that this is definitely going to fix all of those problems that we have. Sorry, excuse me, I've got a bit of a cough at the moment. And then finally, I think all of this stuff works really nice if those source data products are software applications that you're building in-house. But what about external systems? What about the finance application that you've bought as a third-party provider? You really can't control the data that you're getting that in the same way. So you'd have to somehow build some kind of integration on top of it to turn it into a data product as well, which might be additional effort, far more than you would do to ingest it into an enterprise data warehouse. And the same, for like ERPs that contain data that goes across multiple domains. Many people are using large ERP systems that will have all of these things in the same database. So at that point, I think it becomes really difficult to actually work with the data mesh in this way. The same might be that if you have data sets coming from, say, spreadsheets or input files, or some feed that comes from somebody that sends it in on a pen drive through the post, and I have seen that, or floppy disks, I've still seen that. All of those data sources I don't think fit very nicely into this model. So there's an element of work that will have to be done before you could start to really bring them in, which I think is probably more challenging than it would be in a more traditional data warehousing approach. So let's go for a kind of quick recap of the main differences. So although data marts and data products seem fairly similar, I think the scope and the purpose of them, especially at an ownership level, is quite different. With the ownership, we have the requirements for a data mart being provided by the business consuming them. They are owned and built and controlled by the central data team. So there's going to be consistency across the board. Typically, all of the data marts that are going to be built for your customers are going to use the same kinds of technology. They're going to typically be built in a similar kind of way, and that ownership is very comfortably in that space. There's a difference between the pull and the push mechanism here. Sorry, I skipped a bit. So obviously with data products, they're owned by the left, by the domain product teams that are building them. So from all of those kind of points around consistency and technology, they could be radically different. They could be surfacing data in a very different way, each of them. And you probably need to put some governance and controls around how you would do that. I think that comes into the data platform team that Data Mesh kind of recommends you have. But it's not, I don't think it should be an enforced thing. I think it's always better with those kind of things that if you make it easy for them to use, then they will be able to take those tools, run with them, and more likely to do it than kind of reinvent the wheel and do it themselves. So the second aspect is that the mechanism is a pull versus a push mechanism. So with a enterprise data warehouse, you're very much pulling data from the left to the right through various different stages. modeling it throughout, and it's the same people doing the modeling. You'll understand that data as you go on. Everything's done very much with a purpose in mind, to deliver that data. Whereas a data product is pushed out. It's kind of like I create my data product, I create my output ports, and it's almost like a book them and they will come kind of mentality. Create my data product and someone will use it. It's kind of an interesting assumption. It's almost moving it more like a series of third-party data sets that your business might start to choose to use, and it's there if you want to use it. There's some interesting discussions around that piece where you can incentivize people to use them, but you don't want to be doing that in too crazy a way, because you don't want to make it, like a pay-per-use kind of thing, because that might discourage people from using it. You might want to yeah, I agree. I think it's really bad thinking with the build it and they will come attitude. I don't think that is a really good idea. I think it's just going to actually end up with a lot of effort building stuff that people don't necessarily need ultimately. So yeah, I think it's pushing it out there. Let somebody come and use it and see what happens. From the modeling perspective, a data mart, as I said, is centrally modeled. You can then start to combine all of those data sets together consistently, because you'll be including all of them in that model to understand how they work. Whereas with the data product, it's just really not done. So how do I ensure consistency between them? How do I ensure that when I'm consuming these 6 data products here and somebody else is consuming those 7 over there, and then I need to combine those 2 sets together, that we get something that makes any kind of sense? A lot of this is going to be down to how metadata is exposed around things like grain, around things like common keys and so on. I don't think master data management's really been considered in that space. And if you actually read the book, Shamek Degani is quite critical of MDM projects and thinks they're kind of not really any kind of success. And I understand why. I've seen a lot of them fail, but I still think you need to have that kind of centralized language and viewpoint in order to build your data product, your data warehouse from. Whereas with data products here, we could end up with a lot of duplication of effort. If a change is needed, is it an enhancement to an existing data product, or is it an entire new data product that somebody else starts to build? There's a lot of it in my mind that says this comes very close to spreadsheet hell. And so all of that governance side of things, and I'm not a big governance fan, all of that governance side of things will come into play to try and stop those, we'll try and stop those kind of bad processes happening. So if we get onto the pros and cons, criticism has always been leveled at the Inman approach for building a data warehouse, that it's slow and time consuming, it can be a bit brittle, it's reliant on upstream processes that can change, and then it takes a large effort to overcome those, and that everything is dependent on that central data warehouse. So it's kind of like a fan in, fan out approach rather than any other kind of distributed systems being in play. Whereas data mesh is looking to alleviate that. It's looking at borrowing from microservices, borrowing from some of those kind of thoughts that we can start to decouple things, remove some of the dependencies between things, and have things stand alone. And that makes a lot of sense, and I can understand why that seems attractive and people want to do it. From a flexibility and change perspective, as the data warehouse is owned by that single team, all requests go through that team. So it makes them more likely to be a bottleneck and increases the chances that your request will be deprioritized for some other work if you're consuming from it. Whereas I can go to my data product team and say, I want you to change the data product that you build, and that's all that they do. So it'll be high on their list, so long as there's not loads and loads of people asking for them to change it because they built the wrong thing in the first place, because they did the build it, and they will come approach. But all of that stuff comes at that reduction in control. It's not impervious to upstream changes in any case, as we just looked at when we start chaining different data products together. You can end up with a whole manner of kind of problems there. But they are independent, and they will still be able to serve requests from some kind of point of view. And there are different levels of flexibility. So if the data that I need is only from a single domain, it's actually much easier to get it. It's actually much easier for me to say, I just want some baskets data. Go and give me purely my baskets data here. You guys are experts in it. You understand it well. You'll be able to tell me how that works. I can run off and do what I want with that really, really easily. And I think that's kind of interesting. They're only working from their backlogs, so they should be able to do that quickly for you. You get your change done, and great. But there's new blockers for me as well. So I think we've talked about the data platform team quite a lot. They're going to become a blocker. You need them to build a set of tools that are going to be capable for anybody to use and roll forwards with. So you need a really high-tech data platform team there to be able to do that. That there's a lot of effort involved in that. It's going to take some time. It's not like you can just stand that up overnight. And then there's going to be iterations required on that. What happens when a new team comes along and they want to use some new tool that they saw on LinkedIn this week that's the latest kind of flavor of the month tool? I want to use that. Can you incorporate it? Oh, we don't have it in our tools yet, so we're going to have to go and build that. It'll be a bit of time. So there's definitely an issue there. And this governance aspect, it's very close to kind of Inman's spider's web. I think you could very much see that data mesh starts to look like that spider's web of data with lots of things kind of coming out all over the place. And there was a diagram that I did for a customer when I was at Slalom, where the only way we could really draw up the data products that they wanted to build, because they decided they wanted to do data mesh, was to start in the middle and go out. And that's kind of a bit of a red flag for me, especially when these things over here start all connecting together and you've got kind of big arrows circling around the spider's web back to the other side and so on.
Yeah, this is really a fun thing for me about data mesh. That basically the spider's web thing, that's like the anti-pattern of every data warehousing book, is like the target picture.
Yeah, exactly. It's like, oh, let's do that. And it's like, oh, hang on a minute, didn't we not do that because it doesn't work so well and it's a bit crazy and uncontrolled? So I think that's kind of where we're kind of going from with the pros and cons there. So I mean, should you do data mesh and data products? I mean, firstly, for me, it depends whether you have that bottleneck problem, or a lack of transfer of domain knowledge into central platform. If you have that real big bottleneck and it's taking a long time to get things done, and again, I've worked with companies where a request for a change to some data set would be 7 or 8 months before that happened. That's not really sustainable. So something needs to be done to fix that. Is it data mesh? Maybe not. Maybe there's some good things that we can pick from here. Maybe there's some good approaches that we can do. Maybe we could start to look at actually applying more centralized modeling across these data products, but have them a little bit more kind of owned. And I've written a separate piece before around how you could split the ownership of your data pipelines up into those domains and leave those people responsible for it, at least part of the way along. But then from there, you converge into more of a typical data warehousing approach. I think that there's potential things that make sense there. But ultimately, if you have those problems, you need to really consider that ownership aspect. Can you just break up monolith pipelines? If you've got one Airflow job or something like that does everything, that's just a bad pattern to begin with. So you need to start breaking that up and moving it into smaller chunks. You might find that alleviates things. So do you have to do this whole data mesh thing? And definitely, I think if there are the source data products are things like ERP systems like SAP or whatever, I think you're going to struggle. I just don't think that they're geared up for working in this way. If you don't have internal systems that are being built by software engineers that you can speak to and speak to about the changes directly, and they will do them, this approach is not going to work as far as I'm concerned. So it's definitely one for those kind of companies that are, more like technology companies than just general companies. And that's kind of interesting because it's very different from the way in which data mesh is presented, because it's almost presented to those big organizations. This is how we fix your problems. And yet, when I went in to speak to a lot of those companies, they were just not capable of doing that because of all manner of reasons. They're too big. There's too many people too many departments that don't talk to each other. There's too many blockers in the way already. There's too much stuff that's out of scope for data mesh. So data mesh was starting in the middle, and I kind of put a really provocative post out a while ago saying that the purpose of data mesh is to kill the data team. And it got misinterpreted. I'm not saying that data teams are dead, but if you're doing a data mesh, you should, at the end of it, no longer have a data team. You should have these product teams that all do their own thing, a kind of central team at the bottom that are providing infrastructure. But there's no one place to go for data anymore. You go to the domain teams. And yet a lot of the implementations and a lot of the people that are getting excited about it are all data teams that are trying to retro this from the middle. And I just don't think that's going to work. I think you need the buy-in from the people that are building your applications to be able to do this properly end to end. So yeah, that's the end of the kind of ramble stroke rant from a certain perspective. Any questions?
Actually, there was quite the lively discussion in the chat, and I think the questions fall in two main camps. Like the first camp is this kind of seems like either, I don't know, uninformed or like strawman-like, because it's always like an original like 1980s, 1990s data warehousing architecture compared to like the modern approach, but they're like different data warehousing approaches, more modern architectures, more like distributed organizational approaches, different data modeling techniques. So why are they always comparing like data mesh with like original 1980s, 1990s data warehousing stuff?
Yeah, and it's a great argument, and in fact that's the title of the post that I put out when I was at Slalom. Is it just a straw man argument? Is it just something that's set up to be knocked down without really considering what was going on? And it's very much been targeted, I think, at on-premise Hadoop data lakes. And if you have an on-premise Hadoop data lake, then you probably have an awful lot of problems. But it was then put into a space of, oh, actually, if you're a cloud-based if you've got a cloud-based data lake, you probably still have these same problems, but not necessarily, because there's already an element of distribution there. Cloud storage buckets, for instance, are never going to be, you're never going to be hitting kind of max requests or anything like that. You might get some kind of throttling from time to time, but you're not going to hit the same level of problems that you might have with being able to scale an on-premise Hadoop cluster. So yeah, I think it's started from seeing a specific issue and assumed that it's the same across the board, which is not the case. The Kimball Inman argument rages still, and I think this one will go the same. And I know there's a lot of people on here that advocate Data Vault. I'm not a very well versed in Data Vault, so I'm not going to enter into that discussion at all, because I'll get soundly beat, I would imagine. But there's a lot of different approaches to take with data. I think there's some interesting stuff in this mindset, but it's a long way from being fully figured yet.
Yeah, makes sense. And like the other big chunk, I would say, into which like I think most of the questions fell, is this whole like integration and interdependencies business. Like, so how do I integrate data? What about the dependencies? For example, do like the data product people just like build data products in advance because they think someone might need the data at some point, or what happens if like I change my data products and there is like a whole like tree of aggregate data products building on top of that? How does like change management work, stuff like that?
Yeah, so I'll deal with the change management side first. So with change management, if you think of, say, an API, if you're creating an API, you'll have versioning with your API. And you'll generally maintain a number of versions of that API for a period of time and have some kind of sunsetting on there. So, maybe I'm on version 1.3 right now, and I'm supporting everything from version 0.9 forwards, but I've sent out a deprecation notice for version 0.9 of my API. You need to fix it by this date because we'll no longer support it after that. So there needs to be an element of that thinking into your data product. Now, if you're exposing data over an API, that's easy. You can kind of handle that. If you're giving, say, a direct SQL endpoint access, how does that work? Because I'm fundamentally changing my underlying schema probably. So how do I still support the previous schemas that I have? So maybe data virtualization tools can come into play there. Views for building a schema out and so on. With one customer, we looked at saying, okay, if you're going to expose a SQL endpoint onto your data product, always make sure that you do it through views and maybe get into some kind of schema versioning on it. So we'll have like schema v1 dot product, schema v1 dot like product manufacturer table or whatever it happens to be, so that you can still maintain that going forwards. That's a lot of work to do, and it's not always, there will be breaking changes in there as well, so you need to kind of publish that going forward. But hopefully that answers the kind of the versioning. I think that's the approach that you would need to take. From an integrations point of view, for me, this is really important, and getting that data platform team right. I think if you did the data mesh and you ended up being in a data platform team on it, I think that could be a really cool, fun job, because you're just going to be trying to provide tooling for people to use so that these integrations are as easy as possible, which is kind of a really interesting set of problems to deal with. But you need to try and make that easy. And this is where I definitely think that if you have like those third-party sources that are coming in, you've got to have some kind of wrapper around it before you can even get close to starting to thinking about building it on your data mesh. So you're going to have something that actually integrates with that ERP system, builds some data out into its own data product, and then goes forward from there, and making sure that nothing else is circumventing your data product here and going back to the ERP system. That was a big issue that I had with one customer. They already have that issue with their data warehouse anyway, because people just skip the data warehouse and go back to it and do things themselves. So they were, exploring how do you get around that as a problem. But it's a huge. I think it's a really huge challenge. I don't think the technology is there yet to say this is definitely a data mesh platform that will do all of that stuff for you. I'm unconvinced that platform can ever really exist. And whilst again, I put a blog out yesterday about Firebolt, second time I mentioned it. Firebolt could be good in your data mesh for these reasons. It's purely as the database part of it. The rest of it is, kind of stuff that you're still going to have lots of other tooling for. So yeah, I think that's still as yet an unsolved problem. And it's probably why when you look at architecture diagrams for data mesh, they can look wildly different. There are some that look like just a distributed data lake. So if you look at, say, the JP Morgan Chase examples, which AWS pushed out, it's all using kind of lake formation and S3 buckets and the Glue catalog. Whereas you can have other ones that are entirely based on streaming. They just look totally different. You put the two diagrams together and said they were the same thing, you kind of think you're crazy.
Yeah, the fun thing for me is like I've been involved in all kinds of data warehousing projects, both in-house and as an external consultant. And like we had this before, like where we had like a team that was writing some kind of framework for the ETLing and the people who were doing like the actual data transformation work, or we had like different teams being responsible for different subject areas, even though we were using like the same Oracle or Snowflake or whatever. And I think, to be honest, like the only way that data mesh can work realistically is when you standardize on the technical platform. So you can do like all the different teams, and I think you have written a blog post that pretty much goes in the same direction. You can have like different teams, but if like every team can pick their own way of working from a technical perspective, this is just a nightmare.
Yeah, I think so, and it's nice to say that you can have these boxes, and inside that, just let people do whatever they want. But I just don't think that's sustainable for all kinds of reasons. I mean, thinking of just a very basic level, things like licensing. And license consolidation. If somebody starts using a licensed product and somebody else is using a licensed product here, if you don't know about it and it's separate, then you could end up spending an awful lot more on the resources that you have than if you consolidate stuff together. So yeah, I think it's a really important part. I think that team needs to have some time building a platform together that's going to be used. But that's then time where you're not delivering data, you're building a platform. And I've seen other companies, and I've worked at a company, for instance, delivering a cloud platform that never even happened, and it was 6 months of wasted work. So yeah, I think there's definite dangers there.
Yeah, and like I think the third aspect that's now coming out in the chat is like the whole like for what kind of organization is this approach, like does it make sense, and like what kind of skill sets do you have? Because I could imagine you're saying that the data team will shrink and probably disappear, but like the number of data people you need will explode, right?
Yeah, for sure. And the level of data literacy needs to be high. You can't do this where data literacy is low, because it's just not going to work. My actual thinking of where this would work best is greenfield. If you have a small greenfield project, you can start off building this stuff up and iterate on it, and you're most likely to make it work in that way, which is, I find, is really ironic, because it's the exact opposite end of the scale from where the original, a lot of the kind of data mesh material goes. It says, oh, so this is for very large organizations, and there's a cynical part of me, I no longer work in consultancy, that says that's just consultants wanting to sell consultancy time, because you can talk about doing this thing for an awful long time and nobody really knows how to do it yet. So those projects start and roll on and roll on and roll
So
on
it's a
and roll
gold
on
mine.
and roll on. It's a gold mine. Yeah, it's an absolute gold mine. I think back to Slalom, where I was working, and I think back to the projects that I was working on there. I don't think one of them is yet live on a data mesh, and I haven't worked for Slalom since the start of the year. So and they were all projects from quite a while before that. So they're all 18 months in, and there's probably not a lot to show for them yet. Which again is the opposite side of this. So these data products are going to be small iterative things that you can kind of churn out and really kind of roll with and move forward. So yeah, I think there's a lot of potential danger there.
Yeah.
If it's done well, it could be great, but it's just not proven. It's just not proven.
What I find interesting here, like I think Roche Diagnostics is already pretty far in the data mesh journey, but what they have done is they standardize the technical platform, Snowflake and so on. And also it seems like they're not really doing aggregate data products. They're putting data marts on top of data products, basically, to do the integration work.
Yep. And I think that could work. I think if you take that mindset of pushing the kind of source data product thinking into just your standard kind of platforming for a data warehouse as well, that would work. And that was kind of the original blog post that I put out on it, and said, actually, just get those people that build data and data applications to care about data from an analytics perspective. If you can do that, then you get a big tick in a box, and that's going to solve a lot of problems, I think, down the line. Getting them to model data in there, getting them to think about and communicate consequences. And I mean, I have a great example of that from a time when I was a head of data, and one of the teams that was building a product, an application product for me, changed the way in which this was a car finance kind of broker, and they changed the way that an application was assigned to their agents. So previously, an application would be assigned to an agent, and then that agent would be expected to call the customer. And they switched it from allowing the customer to book a call, which is a great piece of technology. And what actually happened was, after the call was made, it was then put into the dialer, found an agent, and then the application was assigned to that agent. and it completely destroyed all of their core metrics, which they were bonused on, because now the time to first call was either a negative amount or just never happened, depending on which way you looked at it from the data. So if you can get those teams to actually care about some of that analytics side of things right from the get-go and communicate, then you can probably alleviate a lot of those problems. And that's, I think, again, where this comment around domain knowledge being lost in the data platform comes into play.
Yeah, makes sense. Like one aspect that I also see in the discussion is, like in the end, you kind of have to do the work of like understanding what your organization is doing, like having some kind of like terms for the things that are going on, some kind of like shared understanding, shared language. And I think this might be harder to achieve in a distributed way of working than in a more centralized way of working.
Yeah, I just noticed there was a comment from Juhai, if I pronounced your name correctly, apologies if not, around if you really want to start doing data mesh, then start with one domain. I would say start with 2 domains. The reason being, if you have one domain, you won't see any of the potential problems of trying to combine those 2 data sets together. And I think that's a really, really important part of it. You actually need kind of like 2 things to start seeing the interactions and seeing what works. If that makes sense. But I wouldn't go beyond that. I think you're right. You need to start small, and you need to think inside those domains as to let's don't do the entire domain. Let's just do 2 little bits of it, and then see how they combine with 2 different sets of ownership and see how it works. So yeah, I think that's the approach that I would take.
Makes sense. I think like one, I don't know, pet peeve or something from my side. Shamak says repeatedly in the blog posts, in the book and so on, it's specifically about analytical data, and I wonder why not about all the data in your organization? If you're already like doing all the stuff, why not think holistically about all the data?
Yeah, I think that argument raged quite a while in the data mesh Slack channel as well. You know, why is there this separation between operational data and analytical data? Is it just a contrived separation? I think it is. I don't see any reason why you would have to do that. I think you could combine all of these things together. People already do horrible things anyway. I mean, there's this horrible reverse ETL craze as well at the moment, which is a kind of fun one. We'll leave that for another soapbox another time. But I think, you know, you could look at actually having these products created, and I think back to an event-driven architecture where I have my applications pushing event streams out to interact with each other. And from a data pipelining point of view, it's really cool because I've got my ETL for free because they're already pushing that data out into a stream, so I can already consume those immutable events. So why can't I push further events out from my data product as well and have applications consume those events? I don't see any reason why not. I don't see why there needs to be another layer of anything that stops that being a valid data point product. And yet that argument rages on, and there are quote reasons why you shouldn't do that I will say I don't fully understand.
Yeah, I think we're on the same page here, because if I look at like a source data product, this is basically just making the operational data available, and it seems it magically turns into analytical data at that point.
Yeah, exactly. All data is analytical data. All data is operational data. And if you think of, you know, the argument starts getting into the kind of place with sort of data science use cases and machine learning and things that are doing predictive, you know, real-time predictive analysis. So back to the car finance broker that I was at, we have, you know, a couple of different models that would run to identify the likelihood of the APR that the customer would get from the various brokers and then bucket them accordingly. So that's done on the fly, and it's retraining on the fly and all that kind of stuff. So is that operational data or is it analytical data? It's clearly both. And trying to kind of segregate that out is absurd.
I think Tanya is raising an interesting point with all these independent data products that are connected in a spider's web way. What about GDPR?
Yeah, I mean,
a big risk of like combining data or using data in an unlawful way.
And I suppose that comes into the again not very mature governance piece in there, and I don't like governance, so I'm not going to go into governance in a big way, but I think it's probably in that space that you say, okay, if we're creating a quote data mesh data product, then maybe just right from the start it does not have PII in, for instance, and you just make it, you cannot have PII in a data product there. Typically, you know, a lot of the use cases that we're talking about in this space, you don't need to see the PII itself. You might need to know that an individual is an individual, but you don't necessarily need to know who they are. So I think that's probably, you know, the kind of decisions that need to be made. But it's completely right. If there's lots of different teams doing that, how do they all know, and how is that enforced? I think there's some serious challenge there.
Yeah, what I'm thinking about, like just last week I was at the German-speaking data world user group meeting, and there was a presentation from a company that has basically some kind of data governance tool that combines like modeling, like from a business perspective, modeling technically, doing all the mapping so that you can generate like ETL stuff from it, and so on. And I think what could work, that you do something data mesh style, but mandate the usage of such a tool. So that like you have multiple teams, but they have to use like this central modeling and governance tool, so that you have this kind of overview.
Yeah, and what I'm hoping is, I mean, I think one of the best things that's come from data mesh is there's a lot of discussion and thinking about some problems that are genuine problems in some organizations. Potentially, a lot of those problems are that they were just doing it wrong, and maybe they could just like rethink how they're doing stuff anyway and do that in a different way. But there's a lot of interesting conversation coming from this, and maybe it's going to push tooling forwards. As Juha says, that in the book it says computational governance aspect of data mesh, and you have all of this that's code that applies it. But yeah, I don't think anybody's really demonstrated how that works yet. I've not seen it, if so. So you know, it's kind of interesting.
Yeah, my experience from like lurking a bit in the data mesh Slack and joining some of these discussions on LinkedIn, so is that many people who are interested in data mesh or wanting to do data mesh don't have this kind of like data management or data warehousing experience that many of the people here in the audience have. And so they just can't imagine what can go wrong, or they can't see what the potential pitfalls. And I think this is a really real danger. This is why I wrote this post about 2 months ago about data mesh being dead. This doesn't mean that like data mesh is bad per se, or that it can't work per se, but I see so many people who don't have a clue trying to do it, that many of them will fail, and it will give data mesh a bad name. And so people will stop calling their stuff data mesh regardless of data mesh being a good idea or not.
Yeah, exactly, and I think you're kind of in the kind of Gartner hype cycle land there. I think they've already declared it dead as well. It's the kind of buzzword bingo world that we're in at the moment with data. And
I think Gartner says like obsolete before reaching the plateau or something, but yeah, it's the same basically.
Yeah, it's kind of, I think there are some good ideas there, but it's very theoretical. It's not very well proved out. I believe there was an implementation that the original material was based on, but for some reason, ThoughtWorks' customer and Zermac's customer didn't want to publish that. I believe they were trying to patent it. So, you know, that's kind of interesting. But there's a long time where people are asking, okay, this is theoretical, this is really interesting, there's some interesting ideas here. How does it work? How does it work? How does it work? And it's just not, it's just not there yet. And I think, you know, we're some way away from really seeing whether this is actually going to be any kind of realistic thing to go forward with, or is it just an interesting thought concept?
I think Henny raises an interesting point. It seems that like most of the new developments we've seen in data in the past 15 years or so, starting from Hadoop and big data and now data mesh, is basically software engineers coming into data and thinking, yeah, those data people are so stupid, we can do it better.
Yeah, for sure. And SQL's rubbish as well, right? We can do it.
Yeah, of course it is.
An API.
Yeah, no SQL, of course. Yeah. Now it's not only SQL for some reason.
Yeah, exactly. And it's not understanding that there's a wealth of experience for data management that's got history for a reason. There's books going back to the 60s and 70s that people need to read to understand where we got to and why we got here. And yet the data mesh material kind of starts pointing the finger around about 2010 at data lakes. And it's like, okay, and yet data lakes isn't really what everybody thinks they are anyway. If you read James Dixon from Pentaho's discussion, a data lake is actually much closer to the data product that we just looked at earlier. And he has this crazy like water garden phrase for a collection of that. So
yeah, and the fun thing again about like data lakes, if I look at like more recent data lake material from like the past 2-3 years, they have these 3 layers in it, and like one layer is raw data, one is like more integrated, the third is more like presentation focus. And I thought, I know that kind of architecture from somewhere. There was this Inman guy like 30 years ago.
Yeah, exactly. It's exactly the same stuff. And
like they call it now like bronze, silver, and gold, but it's like the same thing.
Yeah. Exactly. And it's like, okay, we do this because this kind of works and makes sense. I mean, the argument, the kind of argument, there's a little bit of an argument, I think, for the EL part of ELT rather than ETL, in that you can set something up. If you have an application, you can start just dumping data from it into a bucket and not necessarily worrying about further downstream modeling and just kind of accumulate it there. But you're assuming that the data was modeled in the first place in the application in that case, and you do need to record that it's there. And this, I've seen, again, working with a data scientist, I've seen where this would be beneficial, because then when they're starting to work with that data, they have a data set of volume and of time that they can work with. In this case, they needed a 6-month data set. If we hadn't been just dumping that out somewhere in that system, they would have had to wait 6 months before they could start really viewing what they wanted to do. But the intention should always be to then do some downstream modeling of that data, not to just start using it as it is and throw some kind of crazy Jupyter notebook into production, which happens.
Yeah, I think this is, we're running out of time, but this is really, I think, an important point, that we have all these kind of like stakeholder groups that all have some kind of like IT and data connection, like they come from software engineering, they're like old school data warehousing people, they're data scientists, machine learning, data savvy business people, and in the end, I think they're still not like collaborating enough. Like what I've seen time and again, that you have like 2 data functions in the same organization, like one like the old school BI reporting people and the other like the data science ML. They don't really talk to each other, and often like the data science people rebuild something that the data warehousing people already have, or like the data science people find something out that's really interesting, but it's not fed back into the data warehouse. So like the regular business people don't even know that like this kind of knowledge is there. And I think like the data mesh is like another like symptom of this, that they're like people working with data, not really like talking with each other in a proper way, not really like sharing knowledge in a proper way.
Yep. Yeah, I completely agree. I think it's entirely a people problem. It's coming from people not knowing what's there, not understanding what's there, not understanding kind of why things might be there, and not talking to the people that might understand that. So I think that's interesting. And actually, on the kind of data mesh world, I think there's a kind of interesting point there if we're talking about people and thinking of like people churn in an organization. What happens with some of those crazy data products that have been made that halfway through, that then the guys that built it left, and further down the line, who's taking over that data product then? It's kind of it just smacks of spreadsheet hell in a lot of ways.
Definitely. And I think what doesn't help, that like the data mesh terminology is often not that accessible, like this whole like data quantum, like federated computational governance, or that the aggregate data products are not necessarily aggregates. They are just like combined from other data products, but not necessarily like aggregates in the way data people understand them, stuff like that. I think like about the discussion we just had a few moments ago, there are like the quotes: "Those who cannot remember the past are condemned to repeat it." and like history repeats itself twice. First it's tragedy, the second time is farce. And I think a lot of this is going on in the data world, not only or not necessarily with data mesh specifically, but in like all kinds of corners of the data world.
Yeah, I agree. So yeah, just a couple of last couple of comments in there. So yeah, on the data mesh sounding brittle and not resilient to change. Yeah, I think it could be. And this is the other issue with this, is that all of the data mesh implementations out there are no more than 2 years old max, pretty much, maybe 3 if you. So, you know, in terms of that change and how they work over time, I don't think that's really been seen yet. And then Charles, with regards to metadata, sorry, I didn't see when that popped up. But yeah, there is a part of the data product that would specify having a metadata API as part of your data product that says things like, you know, when it was last updated, what its sources are, and so on. So, you know, there should be an element of that, you know, who created it, where the source code is, and all of that should be accessible from the data product itself. And I kind of like that bit, and I like the bit that they should be self-describing. You know, it should be clear to see what is the data product and what's it doing without having to go somewhere else to see that. But again, these things are, it's how do you enforce them? How do you build them out? What's the answer to that from a tooling perspective? I don't think those are necessarily there yet.
And like one thing I think I'd like to close, because it's like a personal favorite of mine. Like you shared the I think for Twitter comment from Jean-Marc, which you talked about like bitemporal data products. In the book, again, there are a few pages about like bitemporality. And it seems they want to make this the default for data products. And the fun thing is, this never pops up in any data mesh discussions. Like, even though like Jean-Marc stresses this, and there are a few pages in the book and so on. And maybe the reason for this is because, like, I've been talking about bitemporal to people, and usually like their eyes roll back into their head, and this is the end of the discussion. So I don't think that this is something that's very realistic, and people don't seem to pick it up.
Yeah, and I don't think they really picked that up from the kind of the output ports whole piece as well. You know, it's this whole piece of like the output ports should provide that. They should provide, you know, different time sense viewpoints from your data product, different formats, different ways of accessing it. And, you know, I think like if we think of some of the approaches that are put out there, it's like there's none of these different ways of accessing the data ever existed, and it's always ever one. I can access my data through AWS Glue, end of, that's it. I think those bits are really kind of missing, and that they could be really interesting. You know, so a lot of it's about it smacks of basically you're building an API around your data mart from a certain point of view. So if we take our data marts and we build an API around them, would that get us the same kind of common goals and allow us to do various things within there, so that people can access that data a little bit easier than they currently would like to? I'm not sure.
Yeah, actually, at the very beginning, when you had this vote about like data products and data marts being the same or not, I voted for same, because in the end, like, you build them in a different way, but like from the outside, like a data product and a data mart look very, very similar.
Yep.
And like the data products are intended as black boxes, so there are no pipelines visible from the outside and so on. So that was why I voted yes.
Yeah, and I think it's a good point. You know, I think the initial I shared with you initial kind of LinkedIn post that I put out some time ago that prompted this talk. They're saying, oh, they're the same thing, and I'm saying, oh, well, no, the process behind them and the intentionality of all of it's behind them is very different. But from that perspective, yes, they are very, very similar. They provide business level, targeted business level information on a subject, and that's the same. It really is the same. From an end user's point of view, there should be no difference.
Yeah, makes sense. I think I have to wrap this up at this point, even though we could discuss for another hour in the interest of my marital peace. Like it was the Data World Conference last week, I'm doing this today. So I think we have to call it a day. I will share the recording next week. I've already shared the link to the slide deck and then the meetup itself. So thanks a lot, Matthew. Thanks a lot, everyone, for the lively discussion. We'll continue this in some shape or form. Definitely, we'll pick up the topics at the Ghost of Data Warehousing discussion in December, and probably also at the knowledge gap, because I think even though I declared that data mesh is dead, it's not quite dead yet. So I think we will discuss about this for some more time. Thanks a lot. Thanks, Matthew. Thanks, everyone.